In this problem, we're going to find the equation of a line that passes through this point and is parallel to this line. And we need to write our answers in point-slope form and also in slope-intercept form. Let's go ahead and work through its solution. So to find the equation of a line in point-slope form, we just need a point and a slope. So we already have the point, it's given to us. So -5, -5. We just need the slope, which is m. So we're told that our line is parallel to this line. Parallel lines have the same slope. And so if you look at this line, it's already in slope-intercept form. It's in the form mx plus b. So via matching, you see that m is equal to -5 because parallel lines have the same slope, and our line is parallel, so the slope here is -5, so our slope must also be -5. So let's go ahead and do part A. Part A wants point-slope form. So let's go ahead and write down the formula. That would be y minus y1 equals m parentheses x minus x1. So now we just plug in the numbers. So it'd be y minus -5, or just y plus 5. It'll become positive. And then -5, so many negatives. Everything's a -5. -5, it's ridiculous. So on the left here, it'll become y plus 5. And then here it's -5. And this will be x plus 5. Good stuff. This is y plus, oh, so that's the answer, right? This is, I'm going to keep going. This is the point-slope form, so we're done. Now, to get the second part, you keep going, right? You basically solve for y. Whenever it asks you for this, you want to write it like this. So you just want to solve for y. So if we were to keep going here, we would get y plus 5. Then we would distribute the -5. So -5 times x is -5x. And then -5 times 5 is -25. Then you just subtract 5 from both sides, subtract 5. So we have y equals -5x minus 30. And this would be the slope-intercept form. So and that's it. I hope this video has been helpful. Good luck. In this problem, we have to solve this equation for x, and then we have to determine if it is an identity, a conditional equation, or an inconsistent equation. So to solve for x, we have to get rid of these fractions. You'll notice here there's an x minus 3, so it's beneficial to multiply both sides by x minus 3. But at the same time, you have an x plus 5, so you probably also want to multiply by x plus 5. So what we do is we multiply by the product. So I'm going to go ahead and put the x minus 3 here and the x plus 5 here. And it's super important to realize that this whole left-hand side is in parentheses. And then what you do to one side, you do to the other side. So x minus 3, x plus 5. Now let's go ahead and distribute. So we're going to take this and multiply it by each of these terms. I'm going to go ahead and show all the steps too. So it'll be x minus 3, x plus 5, times, and then 9 over x minus 3. We keep the plus sign. Then we do it again, x minus 3, x plus 5 times this second piece here. So x minus 3, x plus 5 times this whole second piece. Okay, so 2 over x plus 5. Good stuff. Now you can skip this step, but I just wanted to show it because most of the time people skip it. And then look, these cancel, boom, 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 boom. We're just left with 28. Good stuff. Now we do get some cancellation on the left here. The x minus 3's go away. And then over here, the x plus 5's go away. So we're left with, I'm going to go ahead and put the 9 first. So 9x plus 5 plus, and then 2 times x minus 3. And that's equal to 28. All right, now let's go ahead and distribute stuff. So 9 times x is going to give us 9x. And then 9 times 5 will give us 45. Plus, and then 2 times x will give us 2x. And then 2 times negative 3 is negative 6. And this is equal to 28. All right, so now we can combine like terms. So 9x plus 2x is 11x. 45 minus 6 is 39. And that's equal to 28. Then we can subtract 39 from both sides. So we end up with 11x equals negative 11, right? 28 minus 39 is negative 11. And then x is being multiplied by 11, so to solve for x, we'll just divide by 11. So divide by 11, divide by 11, boom, there it is. We get x equals negative 1, good stuff. And that's the answer, and you know, you should always check these problems. You take this number and then just like do a mental check. You know, can you plug it back in? Yes, yes you can. So like if you had gotten an answer like 3, that would be a problem because 3 minus 3 is 0, and you can't have 0 on the bottom. Or if you would have gotten an answer like negative 5, that would be a problem, right? Because you can't plug in negative 5. But we didn't, right? We got an answer of negative 1, so that is the solution. As to the second part of the question, this would be what's called a conditional equation. A conditional equation is one which is true for at least some values of x, but not all. So like whenever you have like 1 or 2 or 3 answers, it's conditional. If you have infinitely many solutions, like if it's always true, like if you get something like this, then it's called an identity. And if you get something silly that has no solution, like 3 equals 1, that's called an inconsistent equation. So inconsistent, really bad handwriting. I hope this video has been helpful. That's it. Including a 5% sale tax, an inn charges $109.20 per night. Find the inn's nightly cost before tax is added. Let's go ahead and work through this problem. So solution. So we're looking for the inn's nightly cost before tax is added. So typically what you do in these problems is you let x be the variable that you're looking for. So x is the cost before tax. So it's the cost of the inn before tax. Okay, we need to figure out what that is. So we know that there's a 5% sales tax. So we know that the cost of the inn with tax is going to be the cost before tax plus the 5% sales tax. So that's 5% of the cost before tax. So of means multiply in mathematics. So this whole expression here is the cost with tax. So the cost with tax is going to be equal to the cost before tax plus the actual tax. So 5% of the cost before tax. And this is equal to the cost with tax. So 109.20. So this piece here, just to be really clear, I'm going to put it in a box. This piece here is the tax, right? This is the tax. To figure out the tax on any amount, you just multiply it by the percent. So like if something costs $20 at the store and it's 5% tax, you just do 0.05 times $20, and that gives you how much tax you'll pay. So here it's the cost of the inn before tax, and it's 5%, so it's 5% times x. So if we add that to the original cost, that will give us the cost after tax. All right, let me go ahead and write this again. So x plus 0.05x, I'm going to drop the parentheses here, and this is equal to $109.20. Okay, we have to add these x's. So in order to do that, it's really important to remember that there is a 1 here before the x. It's like an invisible 1, but it is there. And so when you add these, the x kind of just hangs out. You have 1x plus 0.05x. So you just add up the 1 and the 0.05. So it's 1.05x. It's like if you had 2x plus 3x. You just do 2 plus 3 and you get 5x. Same thing here, it's just the decimals. It's a little bit different. This is equal to 109.20. All right, it's being multiplied by 1.05. So to solve, we have to use division. So we'll divide by 1.05. Divide by 1.05. Kind of a cool problem. So this is equal to x equals, let's see what it is. I'm going to use my calculator. So 109.20 divided by 1.05. Oh, wow. Totally rigged. I'm saying that because I got a whole number. So the cost of the inn before tax was exactly $104. I hope this video has been helpful. Good luck. You invested $22,000 in two accounts paying 8% and 9% annual interest. If the total interest earned for the year was $1,860, how much was invested at each rate? Let's go ahead and work through this one. Solution. So there's a few ways to do this problem. You can use one variable or you can use two variables. I'm going to do it with two variables, and then I'll explain how in theory you could only use one variable. So let's let x be what we're looking for. We're looking for the amount invested at each rate. So at 8%, let's do that. So x is the money invested at 8%. So how much money we actually invest at 8%, and we'll let y be equal to the money invested at 9%. And so now we can create some equations with the given information. So it says here we invested $22,000 in two accounts. So that means that the money invested at 8% plus the money invested at 9% is equal to 22,000. So we know that x plus y is equal to 22,000. Now we need to use the other piece of information, the total interest. So the total interest earned was $1,860. So it's important to know how to come up with this. So if you invest X dollars at 8%, then how much money do you make from that? You make 8% of X. This is how much money you earn. So this is earned at 8%. This is the money earned at 8%. So if you invest $100, if X is 100, you would get 8% of 100, so you would get $8. If you invest $1,000, you would get 8% of 1,000, so you would get $80, etc. So we invest X dollars, so we earn 8% of X. Of means multiply. That's why we're multiplying. Likewise, if you do 0.09 times Y, so 9% of the money invested in Y, at 9%, this is the money earned at 9%. That's a sloppy 0.09, okay. So the money earned at 8% is 0.08x. And then the money earned at 9% is 0.09y. So if we add these up, the money earned at 8% plus the money earned at 9% equals the total money earned, so 1860. All right, so this first equation tells us how much we invested. The second equation tells us how much we earned. So the money earned from the first account plus the money earned from the second account equals the total money earned. All right, now we just have to solve this system of equations. So an easy way to do it, I'm thinking, is to, let's get rid of, how about we get rid of the y, just for fun. So let's multiply both sides by negative 0.09, both sides of this equation. So we would get negative 0.09 x, right, multiplying it by negative 0.09, and then negative 0.09 y. Okay, multiplying negative 0.09, negative 0.09. Now let's do it here. Negative 0.09 times 22,000. I have to use a calculator. So that's going to be, I got negative 1980. Okay, negative 1980. Good stuff. So we took this first equation and we multiplied it by negative 0.09. Why? Because now when we add these, stuff is going to go away. Let's see. 0.08x minus 0.09x is going to give us negative 0.01x. And then here, these are going to cancel. And then here we get 1860 minus 1980. So 1860 minus 1980. It's going to give us negative 120. And then you can just divide this by negative 0.01, negative 0.01, negative 0.01. So we end up with 120 divided by 0.01. It's going to be a really nice number. Beautiful. X equals $12,000. So $12,000. So it looks like we invested $12,000 at 8%. So this is at 8%. And if you think about it, we invested $22,000 total. So what's left? Well, y must be equal to 22,000 That's the total invested minus what we invested at 8%. So that's going to be $10,000. So $10,000 at 9%. And you can just do it in your head. The numbers are so nice, right? So if you invest $12,000 at 8%, you start with $22,000. So you're left with $10,000. So the answer for 9% is $10,000. The other way to do this, by the way, well, there's a couple other ways to do it. So first, when we got this system of equations, we didn't have to solve it the way we did. What I typically do is I solve for y and then use substitution and plug it in. I have no idea why I did it this way, but it seemed to be faster, so I'll take it. Another way to do it is the way that is typically done in like homework problems and stuff and like solutions to the homework. They'll say, okay, so X is the money invested at 8%. I don't like doing it this way. I think it's too hard. And then, so that means that 22,000 minus X is the money, this is faster, invested at 9%. So if you invest X dollars at 8% and you start with 22,000, that means you have 22,000 minus X dollars left to invest at 9%. So then you create the equation for the interest earned. So it'd be 8% of the money invested at 8% plus 9% of the money invested at 9%. And that's equal to the total money earned, which I believe was, yeah, 1860. Good stuff. Then you just solve this for X, right? You keep going, and then you plug it back in to this to get your other answer. So a little bit shorter, but I think this equation is harder for people to understand. Again, 8% of the amount you invested at 8% plus 9% of the amount you invested at 9% equals the total money earned. So this is the money earned at 8% plus the money earned at 9% equals the total money earned. A harder problem, and hopefully it made sense. I hope this video has been helpful. Good luck. In this problem, we have to compute various different things. So we have f of x equals 2 of x, and g of x equals x plus 7. The first part wants us to find f og of x. Let's go ahead and work through that. So when you have f og of x, so this is the same thing as saying f of and then g of x. Okay, so it's written just the way it's written here. So you want to work from the inside out. So first you replace the g. So g of x here is x plus 7. So you write down the f again, you write down the parentheses, and then you just replace g of x with x plus 7. That's the first step. And again, it's pretty easy to memorize what it means because look, it's fg, fg. It's in the same order. Okay, then you look at f of x because this is f. So this is f of x plus 7. Well, f of x is just 2 times x. So f of x plus 7 is just going to be 2 times x plus 7. So this basically means you replace x with x plus 7. So you would get, here, I'll do it up here so you see it, x plus 7. Just replacing it, you get 2 times x plus 7. That's all you do. And then just distribute. So we get 2x plus 14. So that would be the answer to the first part. Part B, very, very similar. So for part B, we just have to find GOF of x. So same thing as before. It appears, it is written in the way it appears. So it's g of f of x. You see, so it's gf. And then you replace the inside. So always replace the inside first. So this is g of, and then the inside piece is f of x. So it's 2x. Just replace that. So 2x. And then now you look at g, because it's g of 2x. Well, g of x is x plus 7. So if you were just to replace x with 2x, you would just get 2x plus 7. So this is just 2x plus 7. And that would be the answer for GOF of x. Part C, much, much easier. So we want f og of 2. So we already have a formula for f og of x. It's over here. It's 2x plus 14. So all you do is you just plug in the 2 into your formula from before. So it'll be 2 times 2 plus 14. So you just get 4 plus 14. So you just get 18. So that would be the answer to that one. And then finally, for part D, we have to find GOF of 2. So again, we already have a formula for GOF of x, so we just use it. So we have 2x plus 7, so all you do is replace the x with 2. So 2 times 2 plus 7. So that's 4 plus 7, so we end up with 11. And that would be the final answer. I hope this video has been helpful. In this problem, we're being asked to solve this equation for x using something called the square root property. So the square root property basically says if you have a variable, which I'll call x, and it's squared and it's equal to a number, what you can do to get rid of the squared is you take the square root of both sides, and then when you do that, the squared goes away, and the key point is that you get a plus or minus. That's the most important part. So in this problem here, we're already in a really good place because we already have something squared and it's equal to a number. So right away we can start by taking the square root. So the square root of x plus 4 squared is equal to the square root of negative 25. All right, and again, these go away, the square root and the 2. So you get x plus 4. And then here we're going to get a plus or minus from the square root property. And the square root of 25 is 5, but we have a negative sign inside the square root. So that's going to give us an I. So we get plus or minus 5i. We're almost done. The last thing to do is get rid of this 4. It's being added to the left-hand side. So to undo that, we'll use subtraction. So minus 4, minus 4. So these cancel. And we end up with x equals minus 4 plus or minus, and then 5i. And that's it. We can't do anything else. We are completely done. I hope this video has been helpful. Good luck. In this problem, we have the equation of a circle, and we have to complete the square and write it in standard form, find the center and radius, and graph it. So the first step when we're completing the square is to group all of the x's together and group all of the y's together and get rid of this constant. So let's do that. So we have x squared, and the other x term is this one, this negative 2x. So I'll just put it there, minus 2x. Then we have the y squared, and then we have the minus 4y. And then we have this negative 20, and so we can just add it to the other side, so it's equal to 20. Right, you just do plus 20, boom, it's gone. All right, now we're going to complete the square twice. So we start by writing down x squared minus 2x. And now we have to add something here. So to figure out what to add, you take the number in front of the x, you divide it by 2 and square it. Negative 2 over 2 is negative 1. Negative 1 squared is 1. Boom. Let me do it on the side. You take negative 2, you divide it by 2, and you square it. So that'll be negative 1 squared. So that's 1. Always just take this number, divide it by 2, and square it. Then you write the next piece, plus y squared minus 4y. Then you do the same thing except with this number here in front of the y. So negative 4 over 2 squared. Again, you can do it mentally. Negative 4 over 2 is negative 2. Negative 2 squared is 4. Or if you want, you can go to the side and show the work like this. Boom, 4. So we have plus 4. And that's equal to 20. But what you add to one side, you have to add to the other. So we added a 1 and a 4. So we have to add a 1 and a 4. Okay, recap. Just go over it one more time. So you have x squared minus 2x. Take negative 2, divide it by 2, and square it. Negative 2 over 2 is negative 1. Negative 1 squared is 1. Boom, there it is right there. Y squared minus 4y. Y squared minus 4y. Take the negative 4, divide it by 2, and square it. Negative 4 over 2 is negative 2. Negative 2 squared is 4. Boom, there it is. And then once you add to one side, you add to the other. So we added a 1 and a 4, so we add a 1 and a 4. The next step is just from memory. We're going to take these two expressions and we're going to factor them. How? Just memory. These are called perfect square trinomials. So basically the first one is going to look like this. And you just keep the sign. So always keep the sign and then just divide this number by 2. So you just get 1. 2 over 2 is 1. You keep the sign. Bring down the plus. Do the same thing here. Keep the sign. 4 over 2 is 2. Then here you get 25. So again, here you just divide it by 2, so you get 1, keep the sign. Here you just divide it by 2, so you get 2, keep the sign. This is called the standard form of a circle. To find the center of this circle, all you have to do is switch the signs. So it's negative, so it becomes positive. It's negative, so it becomes positive. Just switch it, switch it. Switch the signs. And the radius, all you do is take the square root of this number here. So the square root of 25 is equal to 5. Boom. All right. So now we have our center and our radius, and so now we can do a rough sketch of the circle. So I'll do it by hand. So here's the y-axis, and here's the x-axis. And so you start from the center. So the center is 1, 2. So that means from the origin, you go right 1 and up 2. So 1, 1, 2, and you put a dot. And that's where we start counting from. So the radius is 5. So that means from the center, you just go up and down, left and right by 5. So I'm going to go up 5. 1, 2, 3, 4, 5. Boom. I'm going to go right 5. 1, 2, 3, 4, 5. Boom. I'll go left 5. 1, 2, 3, 4, 5. Boom. Down 5. 1, 2, 3, 4, 5. Boom. Just go up, down, left, and right by 5, and then you just connect the dots and try to make a circular object. If you're doing this by hand, if you're doing this like for like online homework, which you might be, you just use the graphing tools that they give you. So that's it. There's our pretty good circle. I hope this video has been helpful. In this problem, we have an equation with 2 square roots, and we're going to solve for x. So whenever you have an equation with square roots, you want to isolate the square roots and get rid of them by squaring both sides. So we'll start by subtracting this piece here, this square root of x minus 6. So minus the square root of x minus 6 minus the square root of x minus 6. These cancel. So we're left with the square root of 2x plus 5, and that's equal to 3 minus the square root of x minus 6. Okay, so now we're ready to get rid of the square roots. So to do that, or at least the square root on the left, so we'll square both sides and square this side. So on the left, we're left with 2x plus 5. And then on the right side, one way to do it is that whenever you see a 2, just write it twice. So 3 minus the square root of x minus 6, and then just write it again. 3 minus the square root of x minus 6. Good stuff. So this is 2x plus 5. And then here on the right-hand side, we can just distribute. So we take the 3 and then multiply it by both of these, and then take the square root, multiply it by both of these. So 3 times 3, that's 9. And then 3 times this would be minus 3 square root x minus 6. It's really FOIL. First, outside, and then you do inside. And then the last one is last. Maybe that's why it's called last. Negative and negative is positive. And then the square root of x minus 6 times the square root of x minus 6 is just x minus 6. The square roots go away when you do that. It looks like we have some like terms on the right-hand side. So let's go ahead and bring this one down again, 2x plus 5. And let's go ahead and collect like terms here. So we have 9 minus 6. That's going to give us 3. And then we have minus 3 square root x minus 6. Minus 3 square root x minus 6. It's going to give us minus 6 square root x minus 6. And then we still have the hanging x over here, so plus x. All right, so we still have square roots, so we have to get rid of them. So we need to isolate this piece. That means we need to subtract the 3. Boom, and we need to subtract the x. Boom, beautiful stuff. 2x minus x is x. 5 minus 3 is positive 2. And that's equal to minus 6 square root x minus 6. Oh, this is interesting. A little bit harder than I thought it would be. So there's a minus 6 here. And so I did say we should solve for the square root. However, if we divide by minus 6, what's going to happen is we're going to end up getting a fraction. So let's avoid that. How? Well, let's just go ahead and square everything right now. And we can do that. We can just square both sides like this. So on the left-hand side, we now have x plus 2 squared, which basically means we write it twice. X plus 2. And then here, properties of exponents say that we basically square each piece. So we square the negative 6. That's going to give us 36. And then you square the square root. That gives you x minus 6. So you square each piece. Here's the missing step that I didn't show. I'll do it on the side here. You square the 6, and you square the x minus 6. It's more work to show the step than it is to do it. That happens a lot in math. So 36, x minus 6, boom. All right, let's distribute stuff. So x times x is x squared. And then x times 2 is 2x. Then you go to the next one. 2 times x is 2x. And then 2 times 2 is 4. Did that kind of fast. Foiling. And then here we distribute. 36 times x is 36x. And I think 36 times 6 is 216, but let me just quadruple check. I'm like 99% sure. Yep, 216. 216. Just didn't want to mess up this far into the video. Like, no, start over. So let's combine like terms. X squared. 2x plus 2x is 4x. And then we still have the 4. And then here we have 36x minus 216. So this is a quadratic equation. So in general, like in math, when you have a quadratic equation, there's a bunch of ways to solve it. But pretty much all of those ways usually involve first setting it equal to 0. So let's go ahead and subtract the 36x and add the 216. Oh, this is going to be some fun factoring. So plus 216. This is going to give us x squared minus 32x plus 220. And that's equal to 0. Okay, so now we have to attempt to factor this. So 220, wow, what multiplies to 220? Let's think. Well, I'm thinking really basic here, but 10 and 22, that's going to give us 220. Again, now as we do this, we're trying to think of what can we add to get negative 32. So like 10 times 22 will give us 220. That's an option, right? Another option here for the 10 is 2 times 5, and we can't break it down any further. And then for the 22, we get 11 and 2. So this is, I think this is called like a factor tree, I believe is the name for 220. So now we can try to think about like, okay, how can we get 32? I think, well, 22 times 10. Oh, that's going to give us 32. We didn't even need to go that far. Wow. Wow, that'll work. So here we go. So 22 and 10, right? So I didn't even need to do all this. And they both need to be negative. Interesting though, you see I start the factoring process and I keep going and it's right there. So a lot of times that happens with factoring. You know, if you don't do a lot of factoring, maybe you're a little bit rusty, so that's okay. Eventually you figure it out. Just, you know, take the time you need to go through it. You have a product equal to 0, so you set each factor equal to 0. So x equals 22 and x equals 10. All right, so now we should check our answer. Whenever you have an equation with roots, like we do here, 2x plus 5, x minus 6, let me write it down. 2x plus 5, and then it was, I think it was plus, is it plus square root of x minus 6? Whenever you have one of these, you should always check your answer. So always plus square root x minus 6. And I believe it was equal to 3. Let me just double check one more time. 2x plus 5, x minus 6, and 3. Yup. Yep, looks good. So always. So equations with square roots, it's super important to check. So I doubt both of these are going to be answers. So now we're going to plug them into this. So let's check 22. So we have the square root of 2 times 22 plus 5 plus 22 minus 6, and that should be equal to 3. So this is going to be 2 times 22, okay, 2 times 22 is 44, plus 5 is 49, skipping some steps here, plus 22 minus 6 is 16, and that should be equal to 3. 7 plus 4 is equal to 3. 11 is equal to 3. No, that's definitely not correct. So no good. Let's check 10. Let's check 10. So plugging in 10 now. So check 10. Square root 2 times 10 plus 5 plus, and then square root 10 minus 6. This is a long problem. You know, when people learn this, this is like typically one of the longest problems they do in whatever class they're taking. It's always like, oh wow, the 2 square roots. It's tough. 20 plus 5 is 25. And then 10 minus 6 is 4. That should be equal to 3. So 5 plus 2 is 3. Almost messed up. So 7 is equal to 3. No. So none of these check. Well, that means we have no answers. So the answer is no solution. So there is no solution to this problem. If you're looking for the solution set, like if the question is asking you for that, it would be this set here. This set here is called the empty set. And it's called the empty set because it's empty. There's nothing in it. It's the set with no solutions. The symbol that we use in math for the empty set is this one. So kind of a tough problem, and as you see, it took me a little bit to figure out the factoring. You know, I wrote the numbers down, and it just wasn't obvious. I didn't think that, you know, when you add these, you get negative 32. That happens to me all the time, and it's normal. So it shows that you don't have to be like a master at factoring, and you can always, you know, do trial and error and work through it. So if this doesn't factor, you did it wrong. That's why this step is so important. So if you get stuck here, keep trying, and if you really think it doesn't factor, then you made a mistake somewhere else. Typically, this will always factor every single time. Once you factor this, you know you're going to get it right. I hope this video has been helpful. Good luck. In this problem, we're given the equation of a circle, and we're being asked to write it in standard form, find the center and radius, and then give a rough sketch of the circle. So the first step when completing the square is to get rid of this 12. So we'll add it over to the right-hand side. And then when we rewrite this equation, we just need to make sure that the x's are together, which they are. So x squared minus 4x plus y squared, and that's equal to 12. Okay, so now we're going to complete the square. So in this first piece here, we just write it down again. X squared minus 4x. And then you just take this number, divide it by 2, and square it. So we have negative 4 over 2, and then you square it. So you just get negative 2 squared, so you get 4. So always, you can do it in your head. Negative 4 over 2 is negative 2. When you square it, you get 4. So boom, you just put it there. This one is already done. It's already y squared. Like there's no other y's, so there's nothing you do here. This one is good. So this worked out really nice in this problem. If you had like y squared plus 2y or something like that, then you would do the same thing you did here. But because it's just y squared, it's done. Here we have our 12. Oh, and we added a 4 to this side. That means we have to add it to the other side as well. Really important. All right, so now this piece here can be factored, and it's a trick. It's just a memory trick. Because we added the 4, we've done what's called completing the square. So this piece will factor always, and it will always look like this. And the way I do it is I just memorize it. I keep the sign, and then I just divide this number by 2. So 2. Then we still have our y squared. And then here it's equal to 16. So this is called the standard form of a circle. So the general formula for a circle looks like this: x minus h squared plus y minus k squared equals r squared. That's the standard form, the center radius form of a circle, some people call it. So we just have to find the center and radius from this. So for the center, you just switch the sign. So it's a -2, so the center is going to be, the center is hk normally. So in this case, it'll be 2, see, because it matches. And notice there's no k here. That's because k is 0. So the center is 2, 0. As for the radius, you just take the square root of this number. So r is equal to the square root of 16. So r is equal to 4. Okay, we have the standard form, we have the center, we have the radius. The only thing missing is a sketch. So here's the y-axis, here's the x-axis. So 2, 0 is right here. From the origin, you just go right 2 and up 0. And then because the radius is 4, what you do is you just travel a distance of 4 from the center. So the easiest way to do this by hand is to just go up and down, left and right by 4. So 1, 2, 3, 4. So you go up 4 from the center, and then right 4. 1, 2, 3, 4. Boom. And then down 4. 1, 2, 3, 4. Boom. And then left 4. 1, 2, 3, 4. Oh, there it is. And then now all you do is you connect the dots. Let me use a fun color. Here we go. Well, it's kind of hard to see, but it's a fun color. All right, there's our deep purple circle. And that's it. I hope this video has been helpful. In this problem, we're given a quadratic function, and we're being asked to find this expression here. This is called the difference quotient. Let's go ahead and work through it. Solution. This is actually a calculus problem in disguise, by the way. So if you ever take calculus, you'll do stuff like this probably on your first test. Okay, so the first step in these problems that I like to do is I like to write down the difference quotient again. So f of x plus h minus, and then f of x, and then it's all being divided by h. Okay, so just carefully write it down. Then this is equal to, so now you just have to figure out what this is, this f of x plus h. Well, let me do it up here. F of x is 2x squared plus x minus 3. So f of x plus h basically just means that you replace every x with x plus h. So it's 2, and instead of x, it's x plus h squared, and then plus, and then instead of x, it's x plus h. I don't know why I put it in parentheses, and then minus 3. So this whole thing here is the f of x plus h. So I'm going to write it down here in the problem. So 2x plus h squared plus, and then x plus h minus 3. So we've only written down this piece here, which is f of x plus h. Then we have the minus, and then f of x. Well, what's f of x? That's what's given in the problem. So parentheses, really important because it's 3 terms. 2x squared plus x minus 3. Really, really careful problem. And it's all being divided by, really important. It's such a long line to draw. It's h. Okay, so this piece here, this first piece here, right here in yellow, is f of x plus h. And then this piece here is f of x. Okay. So now we have to simplify this. So this quantity here, this x plus h squared, let me just show you how to do that. Basically, it's just worth memorizing. So the way I memorize it is as follows. Whenever you have x plus h and it's squared, you square the first one. You multiply these and then you double it. So 2xh, just a formula, and then you square the last one. You could like work it out here in the problem, but it's such a mess because then you have to keep writing everything over and over again. It's better just to memorize it. And then plus x plus h minus 3, and then distribute this -1 minus 2x squared, and then -1 times x is minus x. Wow, ridiculous. -1 times -3 is plus 3, so it's really long. And it's all being divided by, all of this is being divided by h. I'm going to pick a brighter color. It's a little bit hard to see. So this is equal to, let's distribute this 2x, this 2 here. So 2x squared, that's that times that. That times that would be 4xh. 2 times 2xh is 4xh. And then 2 times h squared would be 2h squared. Anything happening here? Let's see. Oh, look, the x's go away. 3's go away. That's really good. Plus h minus 2x squared. And it's all being divided by lowercase h. So this is equal to, let's see. Oh, look, the 2x squareds cancel. Boom. So we have 4xh plus 2h squared plus h. And it's all being divided by h. We're almost there. At this point, everything in your numerator should have an h. Like if you have something that doesn't have an h, you messed up. So now we can pull out an h. Let me do it below. So you can factor out an h from the top. So we have h parentheses, let's see, it looks like 4x. And then what's missing here? 2h. Yeah, that'll work, right? H times 2h is 2h squared. H times 4x is 4xh. And then if we want to get an h, we just need a 1, right? Just a 1 all over h. And so this is equal to 4x plus 2h plus 1. And that would be the final answer. A lot of work. And if you're really curious, and if you're still watching this, you made it this far, at the beginning I said use this in calculus, right? So in calculus, the only thing you do, this is just fun. I mean, there's more stuff involved. It's pretty deep. But basically, like, the only thing you would do in calculus is you would make the h 0. And so you would just get 4x plus 1. That's like the calculus step. So it's really the algebra that makes, you know, the calculus hard. That's why this stuff is like so good. I hope this video has been helpful. Good luck. In this problem, we're given a quartic function. It's called quartic because it has degree 4. And we're being asked for the end behavior. So to find the end behavior, you look at two things. You look at the degree. In this case, the degree is 4. So we have an even degree. The degree is basically the biggest exponent. And then the number in front of the term with highest degree. So it would be -7. So that's called the leading coefficient. And in this case, the important thing is that it's negative. So there's something called like the end behavior test. What I like to do is I like to think about a simple function. What is the easiest function in the world that you know that has even degree and a negative leading coefficient? Well, I think that function might be -x squared. So this is an upside down parabola. So if you memorize this function, you can always do a problem like this. And you see here, this falls left and falls right. So the answer here would be falls left and then falls right. And that's it. That would be the end behavior. If instead it was positive, you would have x squared, right? So if it was like a +7, it would be this, and then it would be rises left, rises right. But the negative makes it go, upside down. I hope this video has been helpful. In this problem, we have a rational function, and we're asked to find all vertical asymptotes and holes. So the first step when you're looking for holes and vertical asymptotes is to simplify first, if possible. Any simplification in a rational function, like cancellation, will give you a hole. There's nothing to simplify here, so there are no holes. Okay, if instead it was something like x minus 2, x plus 1, x minus 2, say it was this instead, then you would simplify, and then you would get a whole at whatever makes that undefined. So you would get a whole at 2, right? Because that makes this 0 over 0. But that didn't happen, so no wholes. So after you simplify, which this is already done, you take the bottom and you set it equal to 0. And you solve. So here you just subtract 1 from both sides. So you get x equals -1. And that's your vertical asymptote. So this is your vertical asymptote. It's really important to write the x because this is actually the equation of a line. I hope this video has been helpful. In this problem, we're being asked to give a rough sketch of this function. Let's go ahead and work through it. So the key thing is to remember what function you're going to be shifting. So the parent function or the mother function is y equals 1 over x squared. This is the one that we're going to be shifting. And so what does this look like? Well, here's the y-axis, and here is our x-axis. And this one has 2 vertical asymptotes. It has one right here along the y-axis, and it has a horizontal one right on the x-axis. And the graph, at least to me, reminds me of a volcano. It's erupting like this, look. There it is, there's a volcano. You see how they're both just going up. So we just have to figure out how to shift this. So whenever you subtract a number from an x value in a function like this, you think you're going left, but no, it's backwards. We're actually going right. So we're going to shift this right 5. So we're going to take this entire picture and shift it to the right by 5. So here is the y-axis, and here is the x-axis. So x, y. And our horizontal asymptote isn't really going to shift, right? We have a horizontal line and we're shifting it right by 5, so it's still going to be a horizontal line. But our vertical asymptote is certainly going to go over to 5. So 1, 2, 3, 4, 5. So it started at 0, right? So if you go right, it'll end up at 5. So there's our beautiful vertical asymptote. And now we can draw our volcano function. It'll look something like this. It's erupting. There it is. And there's our perfect, beautiful graph. Just to make sure you got it, if instead it was 1 over x plus 5 parentheses squared, remember it's backwards. Whenever you add to the x, it's backwards. You think it's right, but don't know it's left, etc. So here we're adding 5, so it's going to be left 5. If you take 1 over x squared and you add 5 to this entire y value here, then you're going to go up 5. And if instead you take 1 over x squared and you subtract 5 from the y value, then you're going to go down 5. So as long as you memorize, this here, and you know the shifts, this problem is not too bad. I hope this video has been helpful. In this problem, we're going to solve this inequality using something called the test point method. So the test point method says that you first want to make sure that you have 0 on one side. And then you want to make sure you have a single term on the other side. So we don't quite have that here. So to fix that, we should be able to factor this. Let's try it. So we have parentheses x, parentheses, parentheses x, parentheses, greater than or equal to 0. So we need 2 numbers that multiply to 28 and add to 11. I think 4 and 7 will do the job because 4 times 7 is 28 and 4 plus 7 is 11. The next step in the test point method is to take each of these factors and set it equal to 0. And again, I want to emphasize that this is a step. This is not something that follows like algebraically from this. It's just something that we kind of just memorize and do. It's a process. Okay, so just take each one and set it equal to 0. And then we solve each of these for x. So in the first case, we just subtract 4 and we get -4. And then over here, we subtract 7 and we get -7. So recap. First factor if needed. So in this case, we factored. Make sure you have 0 here. Next step, take each piece, set it equal to 0, solve for x. Next step, put these on a number line. So here's our number line. And -7 is smaller than -4, so it's going to go over here on the left, and then -4 will go here. And so the test point method continues as follows. Basically, you're supposed to pick a number over here, smaller than -7, and you plug it in to this inequality. Or you can use this one, but we'll use this one. If it's true, you shade here. If it's not true, you don't shade. Then you're supposed to pick a number here, plug it into this inequality. If it's true, you shade here. If it's not true, you don't shade here. Then you pick another number over here and you plug it into this inequality. If it's true, you shade. If it's not true, you don't shade. Well, there's an easier way to do it. I'm going to show you how to do it by just plugging in one number. And this doesn't always work, but it'll work in most of the problems and all the problems we're doing. So let's just check the easiest number in the entire world, 0. So 0 is over here somewhere. So let's check 0. So I'm going to take 0 and plug it in for the x. So we have 0 plus 4, 0 plus 7. And we want to see if this is greater than or equal to 0. So we have 4 times 7. And we want to see if this is greater than or equal to 0. So 28 greater than or equal to 0. Yes, that is true. 28 is actually a positive. Yes has one S. It's definitely true. So we're going to shade here. So what's the trick? The trick is the pattern is always shade, no shade, shade, no shade. So it's shade, no shade, shade. You always alternate the shading and the no shading. What if it was, say instead we got -2 greater than or equal to 0. Then it would be no, that's not true. So then what would it look like? This is important, let me show you. So then, in this case, it would be no shade over here on the right, but then we would have to shade in the middle, and then we wouldn't shade here. So if it wasn't true, then you wouldn't shade, shade, no shade. So no shade, shade, no shade. That's if it wasn't true. But in this problem, it was true, so we shaded, no shade, shade. The last part is to write the answer down. So because we have equality here, we're going to use brackets. And remember, the brackets always face the shading. Okay. So now from the picture, we can get the answer. So it'll be -infinity all the way to -7, bracket, union, -4, all the way to infinity. And that would be the final answer. I hope this video has been helpful. In this problem, we have to find the zeros of this function, find the multiplicity of the zeros, and then determine whether the graph touches and turns around at each zero or crosses the x-axis. Let's go ahead and work through it. So to find the zeros, we just take our function f of x and we set it equal to 0. So we have 3 parentheses x minus 5 and then parentheses x minus 7 squared equals 0. And whenever you have a product equal to 0, you can just set each piece equal to 0. You could just divide the 3 away, by the way, if you're wondering. You can just do this, so we don't have to worry about the 3. So we have x minus 5, x minus 7 squared equal to 0. Then you just set each piece equal to 0. X minus 5 equals 0. And then here x minus 7 squared equals 0. Good stuff. In the first case, you just get x equals 5. In the second case, you get x equals 7. So notice there's a 1 here. That's the multiplicity. So the multiplicity is the exponent that you see there. So multiplicity 1. And over here, the multiplicity is 2. So multiplicity 2. You can pretty much do it without doing any work. You can just kind of look at it and say, okay, the multiplicity is 1, the multiplicity is 2. It's really simple if you know how to do it. And then because this is an odd number, it's going to cross the x-axis here at x equals 5. And because this is an even number, it's going to touch and turn around at x equals 7. So these are the answers. X equals 5 is the 0, the multiplicity is 1, and it crosses the x-axis there. X equals 7 is a 0, the multiplicity is 2, and it touches and turns around there. So that would be the final answer. I hope this video has been helpful. Okay, so we have to solve this equation for x. So the goal here is going to be to write both sides as 6 to a power. Because if we could do that, we can drop the 6's. So if you ever have like b to the x equals b to the y, when the bases are the same like this, you can just drop the b's and you get x equals y. So really, really powerful technique. The reason we want to use 6 here is because 36 can be written as 6 squared. So let's go ahead and do that. We'll keep the left-hand side the same. So 6 to the 3x minus 13. And the 36, we'll write that as 6 to the second power. Okay, so now we have the same base on both sides, so we can drop the 6's. So the next step is 3x minus 13 equals 2. Good stuff. So now all we have to do is solve for x. So we're subtracting a 13, so we can add 13 to both sides, so plus 13 plus 13. So we have 3x equals 2 plus 13 is 15. And because the x is being multiplied by the 3, to undo this operation, we do the inverse operation of multiplication. So we divide. So you divide both sides by 3, and so you end up with x equals, well, 15 over 3 is 5. And that should be the final answer. I hope this video has been helpful. In this problem, we have to solve this equation for x. We're going to do it by writing both sides to the same power. Whenever you have an equation that looks like b to the x equals b to the y, whenever these bases are the same, you can just drop the bases and you get x equals y. So here the goal is going to be to try to do that. So we need to figure out what number will work. Well, you see a 4 here, you might think, okay, I can use 4. The problem is you can't think of 32 as 4 to a power. Instead, we're going to use 2. So remember that 2 squared is equal to 4. So we'll replace the 4 with a 2 squared and keep our x here. And then 32 is actually 2 to the 5th. So this is 2 to the 5th power. Now we're almost there, we're not quite there. We have to actually simplify this left-hand side. So properties of exponents say that we multiply. So this is 2 times x. This is 2 to the 2x equals 2 to the 5. And now that we have 2's on both sides, we can drop the 2's. So we get 2x equals 5. And to finish, all we have to do is divide by 2. So divide by 2, divide by 2. And we end up with x equals 5 over 2. And that should be the final answer. In this problem, we're being asked to solve this equation. So the trick is to realize that this is a quadratic equation with e to the x as the variable instead of x. So we can think of this as follows. This is really e to the x squared, right? Properties of exponents say that you can multiply the exponents to get this. Minus 14 e to the x plus 13 equals 0. So it's really a quadratic. So this should factor. So how? Well, it's going to look like this. Parentheses, 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 and this is equal to 0. So here we should have e to the x, and here we should have e to the x. And you can check this. When you multiply e to the x times e to the x, you end up adding the exponents. So you get e to the x plus x, which is e to the 2x. So it certainly checks. Now we just need two numbers that multiply to 13 and add to negative 14. So I think 13 and 1 should work. And they should both be negative. This way they'll add to negative 14. Negative 13 times negative 1 is positive 13. And then if you add negative 13 and negative 1, you do get negative 14. All right, good stuff. And how do you know to do this? Whenever you see a problem like this with an e to the 2x and an e to the x and a number, it's one of these. It'll always factor. It's like rigged. You have a product equal to 0. So now you set each piece equal to 0. So this factor is equal to 0, or this factor is equal to 0. And we just solve each one individually. So in the first case, we'll just add 13 to both sides. So plus 13, plus 13. So we have e to the x equals 13. And then to get rid of the e, you can just take the natural log of both sides. So we have ln e to the x equals ln of 13. And these cancel, right? There's a formula that's super useful in math. It says that the natural log of e to the x is x. This is like powerful. So this cancels, and so you get x equals the natural log of 13. So that's one of our answers. Okay, one of our beautiful answers. And then here you add 1, so plus 1 plus 1. So we get e to the x equals 1. And the same thing, to get rid of the e, you just put the natural log on both sides. So ln e to the x equals ln 1. And these cancel, so you get x, and then this is just ln 1, which is 0. Okay, which is 0. I'm leaving it as ln 1 because I believe the next part of the question wanted us to write without logs. So without logs, the natural log of 13 in my calculator is approximately 2 I don't know how many decimals the problem wanted, but 5, 6, 9, 4, 9, 3, 5, 7. I'll just put a bunch of decimals. So that's the approximation. And then here, this is just 0. Okay, that's just 0. And that's it. I hope this problem has been helpful. Good luck. In this problem, we have an equation with 2 logarithms, and we're going to solve it. So the first thing we'll do is we'll combine these logarithms. So whenever you have a plus sign, you can combine the logs by using multiplication. So this piece here, because it's plus, is going to be turned into the log base 4 of x plus 6 times x plus 3, and then this here is equal to 1. The rule here basically says if you have the log base b of x plus the log base b of y, that's equal to the log base b of x times y. So the addition turns into multiplication. All right. Now we need to get rid of this log. So what we can do is we can exponentiate. Basically, we're going to put a 4 here. We're going to put a 4 here. And when you do that, what happens is these cancel. And so you're left with x plus 6, x plus 3. And here there's a 1, so it'll be 4 to the 1, which is 4. Okay, and you can always do that if you have, say you had log base 3 of x plus 2 equals 4. Then you would put a 3 here, you would put a 3 here, these would cancel, you'd get x plus 2 equals 3 to the 4th. So same idea, right? So the idea is that to get rid of the log, you just use the number that's here. So, and that's called exponentiating. Really, really, really powerful stuff. All right. This is a quadratic equation. So what we'll do now is we'll multiply everything out and set it equal to 0 and try to solve it. Let's go ahead and distribute. So we'll take x and multiply by x. It's going to give us x squared. And x times 3 is going to give us 3x. So x times x squared, x times 3, 3x looks good. Then you do the same thing with the 6. You just take the 6 and multiply it by both of these. So it'll be 6x, and then 6 times 3 is 18. And this is equal to 4. We can subtract the 4 and combine like terms. So minus 4, minus 4. So we have x squared. 3x plus 6x is 9x. And then 18 minus 4 is 14. Yeah, it looks okay. And that's equal to 0. All right, now comes the fun part. We have to try to factor this. This should factor. If it doesn't factor, that means you did it wrong. Whoops, I erased my 0. So let's see, x, this is equal to 0. So what multiplies to 14? Well, 2 and 7. Oh, and those add to 9. Pretty easy. So we just need a 2 and a 7. So we set each piece equal to 0. So x plus 2 equals 0. And then x plus 7 equals 0. And subtract 2, so you get negative 2. And subtract 7, so you get negative 7. So these aren't the answers. Whenever you have an equation with logs, you should always check your answers. So let's go ahead and write down the original problem again. It was log base 4 of x plus 6 plus log base 4 of x plus 3, and we said it was equal to 1. Okay, so let's plug everything in here into check. So let's check -2. Let's do that one first. So check -2. It's really important that you check with the original equation. So log base 4 of -2 plus 6 plus log base 4 of -2 plus 3. And this should be equal to 1. So when you add here, you just get 4. So you get log base 4 of 4, and then plus log base 4 of 1, and that should be equal to 1. So this is going to be 1, okay, because the question you ask is 4 to what power is 4? 1. And this is going to be equal to 0, because the question you ask is 4 to what power is 1? 0. So again, the first one is 4 to what power is 4? 1. This one is 4 to what power is 1? 0. And then here you get 1. I hope I said that right. So the first one is 4 to what power will give you 4? 1, right? 4 to the 1 is 4. And this one is 4 to what power will give you 1? 0, because 4 to the 0 is 1. So you get 1 equals 1. So that's true. You know, you could put this in a calculator. Like you could do it like this. If you have log base 4 of 4, write it as log of 4 over log of 4. Oh, look, it's 1. But you can put it in a calculator like that. You're allowed to do that. It's just the log of this number divided by the log of this number. So like for this one here, it would be the log of 1 divided by the log of 4. It's called the change of base formula. It's just log of the top divided by log of the bottom. Always works. So this one works. So now we just have to check -7. So let's check -7. So we're going to plug it back into this equation here. So we have log base 4 of -7 plus 6 plus log base 4 of -7 plus 3. And that's equal to 1. So it becomes log base 4 of -1. Okay, and then we stop. And the reason you stop is because this is no good. You cannot take the log of a negative number. Like if you were to keep going and like use properties of logs, it would check. But it would be wrong because this doesn't make any sense. So you have to stop when it doesn't make sense. So you can't take the log of a negative. So that's it. The only answer is -2. I hope this video has been helpful. In this problem, we have an equation with 2 logarithms, and we're going to solve for x. So the first thing to do, solution, is to combine the logs. So because we have a minus, it's going to turn into a fraction. So the subtraction turns into a fraction. The rule is if you have log base b of x minus log base b of y, that's equal to log base b of x over y. So it'll be log base 3, I'm going to use a bracket, of the top part, so this one here, x plus 17 over, and then the bottom part, so this one here, x minus 9. And this is equal to 3. So now we just need to get rid of the log. So what you can do to get rid of the log is you can do something called exponentiation. So because the base here is 3, what you do is you put a 3 here. So now this whole thing is your exponent. Same thing here, you put a 3 here. So now this 3 here is your exponent. And what happens when you do this is that these cancel. So you're just left with x plus 17 over x minus 9. And then 3 to the third power. 3 to the third power. All right. So again, if there was like a 2 here instead of a 3, then you would put 2's on both sides. Just use whatever number is the base and it'll get rid of the log. Let's go ahead and clean up these fractions. We'll multiply both sides by x minus 9. So x minus 9 and then x minus 9. So these cancel. So you get x plus 17 equals, so 3 cubed is 27. So this is 27. X minus 9. Wow, big numbers. I have a calculator with me here, so that's good. So let's distribute that, that 27. So x plus 17 equals 27 times x is just 27x. And then 27 times 9, I mean, we could do it by hand, but I don't want to mess up. So I got negative 243. Boom. All right, this is kind of nice because we don't have like a quadratic here. A lot of times when you do these problems, you have like x squareds, and so this is linear. We just have x. So all we have to do is find x. I'm trying to think what's the best way to do it. I don't want to subtract the 27 because it's going to make it negative. So I'll subtract the x. So if 17 equals 26x minus 243. Then now let's add that 243. It's funny how I don't like negative numbers. It's common, I think, for people to like say, hey, I don't want the negative there, so let me, instead of subtracting the 27, we subtracted the x. It's kind of weird how that works. 243 plus 17 is 260. Oh, this is nice. And this is equal to 26x. And I say it's nice because look at the nice answer we get. When we divide by 26, we get x equals 10. Beautiful. So we should definitely check our answer. So I'm going to scroll back up and check. Whenever you have logarithms, you're always supposed to check. So when we check our 10, we're going to plug it back into this original equation. Okay, so let's check 10. So we have log base 3 of 10 plus 17, which is 27. I'm just showing all of the steps. Minus log base 3 of 10 minus 9. I usually skip steps. Like if I was just doing this and rushing through it, I would just write 27. So you can skip steps. This is log base 3 of 27 minus log base 3 of 1. And this should be equal to 3. So let's see. So log base 3 of 27, how do you do this? You look at this and you say, okay, 3 to what power is 27? So 3. Minus log base 3 of 1. How do you do that? Well, you ask 3 to what power is 1? 0. So 3 minus 0 is equal to 3. So 3 is equal to 3. Yep, so that's the answer. So 10 is actually the answer. Now, if this is confusing, you can do this. This is really a nice way to do it. Just write it as a log of the 1 up top. So log of 27 divided by a log of the 1 on the bottom, log of 3. Then just put this in your calculator and you should get 3. Okay, it's called the change of base formula. So just take the log of this, divide it by the log of this, and it'll give you 3. I hope this video has been helpful. In this problem, we're given a system of equations, and we're given a point, and we're being asked to determine if this is actually a solution to the system. So this will be a solution if it's a solution to every single equation. So let's just go ahead and plug it into every single one and see if they're all true. So if they're all true, it's a solution. If even one of them fails, then it's not a solution. Let's do it over here. Let's check the first one. So x is 4, y is minus 7, and then z is 7. And this should be equal to 4. So these cancel, so 4 is equal to 4. So the first one checks, right? So we plug in 4 minus 7 plus 7. The 7's cancel, 4 equals 4, it checks. Let's check this one. I'll do it down here. So 4 minus 2 times y. Y is negative 7. Minus 2 times z, which is 7. And this should be equal to 11. Again, we're checking this one. We have 4 minus 2 times negative 7 minus 2 times 7. So far, so good. So 4. Negative and negative is 14. Is positive, so we have positive 14. And then here it's minus 14. And this is 11. Oh, look at this. 4 equals 11. So the answer is no, right? Because it has to be a solution to every single one in order for it to be a solution. So the answer to this question is no. This point is not a solution to the system of equations. Again, it would have to be a solution to every single one in order for the answer to be yes.
Hi, in this problem, we are being asked a very interesting question concerning continuously compounded interest, and we're given the formula, which is A equals P times e to the RT. So we're told the amount invested, which is $7,500, the interest rate, which is 13%, and we're told that the accumulated amount is double what we start with. So let's go ahead and find the time in years required for this to happen. So solution. So I'll start just by writing down the formula again. So A equals E times E to the RT. And we're looking for T in this problem. And basically what we have to do is we have to fill in the other variables with the information that's given. So the amount invested, that's going to be capital P. Okay, this is the principal. P stands for principal. This will be equal to 7,500. And then we have E. R is the interest rate in decimal form. So 13% as a decimal is 0.13. 0.13. And then we don't know what T is. We have to find it, so that's just T. Okay, and then the accumulated amount is double what we start with. So basically it's double 7,500. So that'd be $15,000. We have to solve this exponential equation for the value of T. Okay, so we'll start by isolating the E. Since it's being multiplied by 7,500, we'll just divide both sides by 7,500. Then divide over here by 7,500. These cancel. And then 15,000 divided by 7,500 is just 2. So we get 2 equals E to the 0.13 T. To get rid of the E, what we can do is take the natural log of both sides. So this is the natural log of 2 equals natural log of E to 0.13 T. And the reason we did this is because there is a super powerful formula. It says if you have the natural log of E to the X, you just get X. This is because the exponential function and the natural log function are inverses, so they undo each other, and that's what happens. You basically just get X. So this basically cancels. This goes away, so we get ln2 equals 0.13t. Okay, and then to finish solving for t, we simply have to divide by 0.13, divide by 0.13. So we get t equals natural log of 2 over 0.13. And I'm going to go ahead and put this in my calculator. Let's see, natural log of 2 divided by 0.13. So I got 5.33 years. And I don't know if the original question has units. It wants 1 decimal in the original question. I didn't write the original question here on the screen, but it does want 1 decimal. So that would be t equals 5.3 years. So in 5.3 years, if you have some money, it will double at 13%. So if you can get a 13% interest rate compounded continuously, your money will double in 5.3 years. I hope this video has been helpful. Good luck. Hello, in this problem, we're going to graph this absolute value function. Let's go ahead and go through its solution. So there's a couple different things happening here, and I think for me, the easiest way to go through this is to think about just the regular absolute value function. That's given by y equals absolute value of x. And if you remember from before, the absolute value function looks like a v. So it basically just looks like a v like this. So this is the graph of the absolute value of x. But you'll notice we have a negative sign here outside of the absolute value. So whenever you have negative absolute value of x like this, basically it's an upside down v. You have a reflection across the x-axis. So basically it's going to look like this. So this would be negative absolute value of x. So we have a reflection across the x-axis. I'm going to write that down. So here we are reflect. Let me just say reflect across x-axis. Okay, and that's because the negative sign is outside of the function. Whenever it's inside, it's across the y-axis. So just as a quick recap, in case you're curious, if it's negative f of x like this, so it's f of x is y, so the negative is on the y, then it's across x-axis. And if it's in front of the x, it's across the y-axis. So it's opposite. If it's in front of the y, it's across the x. If it's in front of the x, it's across the y. That's how I memorize it. Just a cool little cheap trick. Okay, so now we're doing some other stuff. So we've got an upside down v. And again, we know that because we have the negative here. Now we're subtracting a number from the x value. When you subtract a number from the x value, you go right. If you add a number, you go left. So we're going to shift right 4. So shift right 4. Again, when you add to the x, it's left. When you subtract from the x, it's right. And then we're subtracting a number from the function. So we're going to go down 5. Down 5. If you add to the y value, you go up. If you subtract from the y value, you go down, which should make sense graphically, right? If I add to this y value, I'm going up. If I add to the y values, I go down. Except whenever it's with the x, it's opposite. So subtract, you go right, add, you go left. Okay, so now all we're going to do is we're going to take this upside down v and we're going to shift it right 4 and down 5. So let's go ahead and draw the y-axis and the x-axis. So there's x, there's y. And so from this piece here, from the origin, we're going to go right 4 and down 5. And I'll just do this. 1, 2, 3, 4. 1, 2, 3, 4, 5. And I'll put a dot right here. And then I'll just draw the upside down v. And I'm not going to worry about finding the intercepts. You could if you wanted to. Let me just extend the graph here. So this will eventually cross here. If you wanted to find the y-intercept, what you could do is you could plug in 0 for x. Let's just go ahead and do it for fun. So putting a 0 where the x is will give us negative, and then absolute value 0 minus 4 minus 5. This will give us, again, the y-intercept. Just plug in 0 for x. This is negative absolute value negative 4 minus 5. The absolute value of negative 4, by the way, is 4. So we just get negative 4 minus 5, so we get negative 9. That would be the y-intercept. And that agrees with the graph, right? Because it's way down here. In any case, the main idea in this problem is that you realize that there is a reflection across the x-axis. You're shifting to the right, and you're shifting down. So you have both a vertical shift, a horizontal shift, and a reflection across the x-axis. And that's a very, very rough sketch of the graph. I hope this video has been helpful to someone. Good luck.